Hey everybody, Carl here. Now, tonight we're going to take a look at amplifiers, how we can amplify our signal that comes out of our crystal radio. I wanted to start out with the most simplest thing we can do, and that's the LM386. Now I want to show you something on here, if I can, because I don't have a pencil like I should have. LM386, normally if you see the little cutout and the dot, that's number 1, okay? And it goes 1 through 3, 4, it jumps over here, 5, 6, 7, 8. Now, when you look at a lot of schematics on this, you'll see they'll have resistors coming off and a bunch of capacitors for filters and everything. And those work great. And later on, we will go over that. But I want to show you something really, really basic, simple. Okay, we've got the LM386. Right now, I've got it set up on my bench to run through 9 volts. You can have it run from anywhere from 3 to 18. I think it works best around 9. Okay, now normally you would have a coupling capacitor here going in, and you would even have a coupling capacitor going out. The first thing we're going to do first is we're gonna skip the capacitor completely, and we're going to run directly in, and we're going to go to our pin number 3, which is our input. Now pin number 2 is like negative input, so that we can just run that off of our negative rail. We just do that. And number 4 is our ground, so we run that there too. So we've got, so far all we have is 2 and 4 running to ground. Our inputs running to 3. Now up on the other side, 5 is the output, and we're not even going to use this capacitor. We're going to run directly into the speakers. So we're running 5 directly into the speakers, and 6 is our power input, and that's all we're going to use. We're not going to put the jumper on here and give it better gain or none of that. We're just going to run right now. We're just going to use these 5 pins without any capacitors or anything. I'm going to show you just how good this really works. So let me, I've got one of my old videos on, so we don't get popped, but here we go. I'm running this through, this larger speaker and plus my little teeny speaker. So it's pushing 2 different speakers right now. And how do I control the volume on this? I use the volume control on the phone right now. So let's see what happens if, okay, let me crank the volume up here.
So your ground's connected to your earphone, and it's connected to your capacitor. So that's what I have here.
So you can hear it coming up a bit.
Real simple setup.
And then take it back down. Okay, but I just wanted to show you that's super simple. And one cool thing about this, I was kind of in the comments mentioning to Ron C. One time when he kind of needed a circuit tracer. Believe it or not, if you were to take just the way it is right now and put a capacitor on this line here, because you want to protect it from DC voltage coming in off of whatever you're testing, but you hook a capacitor up to here, and you can even use the other outline, the other wire, as your probe, and you could run through and you could use this as a signal tracer. Hook it up to a little teeny speaker like that there. You don't need a big one, just a little teeny speaker, and you'd have a tracer. But the neat thing about this, if you really want to, you could use this as an amplifier for your crystal radio. Now, in this configuration, this is not that powerful. Now we can put a 10 microfarad capacitor. We can jump 1 and 8, and it will give us like crazy gain. So you want to keep that in mind too. But once you start getting loud, then you're going to start. You got to remember, you're going to start picking up noises. You're going to pick up this, and then that's when you're going to probably want to go to the more sophisticated circuitry. You know, look at one of those schematics that show you how to filter everything out. And it's not that difficult, and it doesn't take that much. But I wanted to show you this. Okay, now let's take a look at a transistor, and I think this is going to be a lot of fun. Give me a second here. This is the transistor setup we're going to be looking at right now, and it's called a common emitter setup. And if you notice, it's pretty simple. We have our input coming in. Now, you know, you can. Right now, we're talking about using capacitors as an option. And as I said, you know, as you build it, you'll make it more refined, make it better, blah, blah, blah. But right now, we want to just learn about the basics. We still have 9 volts on our positive rail. Now, for R1, this is the load resistor. We call this the load resistor, and it connects the positive rail to the collector. All right, and I mean, and there's other stuff here too, but just think of that right now. It's connecting the positive rail to the collector on an NPN transistor. And by the way, this will work pretty much on just about any NPN, any basic. You know, these rules pretty much follow the same. Okay, the emitter, we got that going straight to the negative rail. Then we have our input on the base. Now what we have here, this is what's called the self-biasing resistor. Okay, and there's several different ways you can bias a transistor. This is one of the easiest ones. Now, if we have a 1K up here, we have to figure out what this is going to be here, and it's going to be a lot more. Okay, it's going to be a minimum of 10,000 or 10K, probably closer to 100K. Normally it's like one, you know, the load resistor is probably about 1/10 of the, or even 1/100th of the biasing resistor. Now, how can we? Well, you know, one thing, we can do a little bit of math and figure that out. Like we could take the load resistor and times it times 100, and we'd get 100K, right? And that's, you know, we don't want to do a lot of math. We can, and you know, and for the math geeks, they've already got this figured out. But another way you can do this is you can keep trying get in the ballpark, and then try your biasing resistor and keep and do a voltage measurement. Like we got 9 volts here. Well, ideally we want to have cut that in half and have half of that on the collector. So we basically we got 9, so we're talking like 4.5 volts right here. So between these two, we can get that. Now, so we take and put that, like I said, near, you know, times 100. Take this, times it 100, and start working in that area there. Now, if you have a decade box, a resistor decade box, like up there, this is what I've done. I've hooked the lines up, and I've got them feeding in to the breadboard, so it's hooked up like the resistor would be right here. And let's start out. Let's see, what do I have right now on it? I know it's hard to see because of the light. Right now I have 120,000. So I'm real close to 100K. Well, let's put it on 100K and start there first. And we'll see. And just by listening to it, we'll get an idea of what we think sounds best. We don't even take the voltage measurement yet. We'll see how close we can get it. So let me give me a second. I'm gonna turn all this on. Okay, you can hear me talking there, and we won't, make it too crazy. Right now, I've been dialing it around, and I've got it on 003, and 3 came in pretty good. Let me go to 4.
And basically,
4 works even better.
you would take this line.
Let me go to the next one. No, that don't sound good at all. Let me back up.
And then you go to the speaker. So
Go to 2.
You can eliminate the earphone if you don't want to go out and buy an earphone. Now I tell you, there's I can't think of it.
So we got 102
site right now.
point
There's a lot of science stuff in that.
102K.4
I'll try to put a
basically.
link down
And
in the,
that's coming in
description
pretty
box.
good. Now imagine we could play
Pretty
around a
sure
bit,
you can build
but
your own variable
and I had to turn it down.
by using
It was like
codes.
screaming because while I was trying to get it dialed in. So it's a lot lower on the volume on the phone than what I had it. But right now I've got, I have and this is a 2N2222A, and I got it running to that. I got it jumping over into the capacitor, or into the LM386. Let me shut this off for a second now. I'm gonna turn it off just so we can hear. I got, the furnace is running because it's been like below 0 now for a record length of time, and it's like horrible. We actually got up to 15 here, heat wave, but it's going back below. It's going to be even colder the next couple days. So I know that has nothing to do with what we're doing here, but I just had to gripe a bit. My furnace is running non-stop just about, anyway, and that's the noises. I can't help it. So like I said, I've got the 2N2222A for our transistor. I have it set up like this right now. I've got the 1K as the load resistor, and I got it set up for 102K.4 for the self-biasing, and that's where it came in pretty darn good. Now the next thing to do, I suppose we could test, we just did that by ear. We didn't do anything, no math, or except for figure out about 100 times what is the on the load resistor to get us in the ballpark. So give me 1 second. I'll set up, and we're going to set up the meter to take a voltage reading and see exactly where we're at. Okay, we got another video going, so we got some kind of sound coming through here, and I've got the our power is set to 9 volts, and with this running through, it's right at 9, and it's picking everything up, as you can hear. And that's where the advantage of having the filters in this circuit really comes into play. But right now we're just doing basics. So let me let me go here and see what we got coming in. And we got basically 8, 9, pretty much right, right up there with 9 volts. Now let me. Okay, here we are. You can see we got 8.8, 8.9. That's voltage coming in. Now, doesn't matter what I do up here. It's not going to really. I keep knocking things. Okay, there it is. 8, 9 again. Now that's our positive rail. That's what we have right now. Now with our setup, let me see what we can get. Hold on. I'm not going to leave that on. But see, we got 4, 6. Yeah. Okay, I didn't want to run that real long because I know it was really loud. And maybe in editing, hopefully I can get that to make it even lower. But with this setup here, you got to remember that on the breadboard we have all these wires going off all over everywhere. The line is coming out of my phone, and it's it's on gator clips hooked to the other connector, running into more gator clips and lines and stuff. So you got to remember, you're not going to have like a really nice sound when you first do this, especially on the board. Now, if you put it on a perf board or you make your own PC board, which I want to do that later on too in this project, you'll knock a lot of that down. But actually the best way to knock it down is to use the filtering that they show you how to use most of all on the LM386. Like I said, right now we're just trying to find values, and that's using the self-biasing technique. We've kind of done that. And what we ended up with? We ended up with 130K for our biasing resistor, and that seemed to turn to be the best out of all of it. So that worked. Like I said, we used real basic math, if you want to call it, by taking our load resistor and times 100, and that's where we started, and it got us in the ballpark. But then we dialed in and kept messing with it. Now, if you don't have a decade box, if you don't have, get a bunch of resistors around that value and start plugging them in and see which one, first of all, it'll sound better, it'll start to sound better, and watch your voltage. If your line voltage like this one was 9, you're looking to go around 4.5. Well, we hit, by the time we dialed it in, we got, instead of 100K, we got 130K, but we got it at 4.6, and it dialed in pretty good. It sounded pretty good. So we could probably go with that and not have a problem at all. Now, like I said, this is a real simple little circuit right here. Okay, this is, and there's other ways. You can do a fixed bias where you use 2 resistors on the base and you use it as a voltage divider. There's pros and cons to all these. I like this one because it's the most simple. I can usually set up a small amplifier with a transistor, and and here's another deal. If I wanted to, I could run this output that's coming off the collector. I could run that into another base on another NPN and boost it up even more. And I can have, and then that, I could actually have set that up, and there's small circuits where that would actually run a speaker. So, or you could do that and run it into the 386 like we're doing now. There's all kinds of different ways that we can amplify this circuit. And you know what the thing is, those little LM386s, they're pretty cheap. We can get NPN transistors. You go on eBay, you can get handfuls of them for cheap. So, I wanted to cover this right now. And I'll tell you what, if you like the transistor deal, if you go to talkingelectronics.com, they have a selection there of, just so much information. So many PDFs in just about every area you want to look at. But the one I really like, and I've studied a lot, and I've used a lot of the circuits, and it's helped me learn. It's amplifying transistors, part 1 and 2, and then they've also got 2 PDFs that have 100 transistor circuits, and then the part 2 is like 100 to 200. So there's like, they have a lot there. And if you want to learn about transistors, that's one good place. There's a whole bunch of other places. But for right now, I'm going to cut this right here because I got a ton of editing to do because it was so noisy and loud. And, that right there is kind of a little bit of a mess. I mean, you got to admit it. And had a lot of interference going. Even though this isn't a radio, this still picks up sounds, and I've got the furnace running and everything. So anyway, I just wanted to show you this right now. If I was you, set this circuit up and mess with it and see what you can do. And here's the thing. Here's one thing I'll leave you with. This doesn't have to be 1K. This can be like 22K, and then this will run into this will run into the megs. I know on that book they have they use this as 22K, and this ends up being 2 point something megs. So I mean, and as long as the ratio is good, and as long as you get that divide of the positive rail, it's going to work. And here's another thing, is once you have the ratio together, you can change the voltage of the rail and it should still work because you still have a balance there. So anyway, like I said, I'll cut this one short, and we'll get into some a little bit more complicated filtering in the next one. Until then, everybody, take care. I want to thank everybody for staying with me, supporting the channel by watching and subscribing. We just had 700 subscribers. That don't say, well, it's not a lot, when you compare it to the big channels. But to me, for what I'm doing, it's a big deal. So I just want to say thank you, everybody, so much, because I know at times I have big gaps in in providing content and stuff. So anyway, have a great day, night, wherever you're doing, whatever time you're doing it, and I will see you on the next one. Bye.